All right. So last week you were introduced to the concepts of means and standard deviations. Those are going to be very important this week as we talk about z-scores. Now, just to clarify something, when you're looking at your data set, when you're looking at your groups of scores, when you're looking at your participants, there will be one mean and there will be one standard deviation for the group, right? There's an average for the group, and there is a number that represents how close the scores tended to fall towards the mean. That's your standard deviation. So for any data set, you're going to have one mean and one standard deviation. So now let's talk about z-scores. You know how I gave you the example to think of a standard deviation like a step? Like how many steps away from the mean am I? Your z-score is a way of conceptualizing that. Your z-score represents how many standard deviations away from the mean am I? That's all it means. So a z-score, how many standard deviations away? At the appendix in the back of your book, Appendix A, I believe it is, gives one of the important calculations that we can do with this. Using z-scores is how we're able to say things like only 12% of people scored higher than I did on this exam. That's how we're able to come up with those types of calculations. So first and foremost, the math behind a z-score. So if a z-score is how many standard deviations away from the mean am I, if you keep it in that context, the math is actually very simple. Let's return to our example of an exam. All right. Let's say I gave an exam. The average was 50. The standard deviation was 10. Let's keep the numbers nice and simple. Okay. Let's say I scored a 60% on this exam. I want to know how many standard deviations away from the mean am I? How many steps away from 50 am I? How am I going to math that out? Well, I scored a 60 and the mean was 50, right? So what I'm going to start with to calculate my z-score for z equals, can you see that? Yeah, kind of. For z equals, I'm going to start with my score minus the mean, right? The mean was 60. No, the mean was 50. My score was 60. My score was 60. The mean was 50. I'm 10 points away from the mean. So I'm going to do x, which is the score that I'm considering, minus the mean. So that's step one, right? In terms of raw numbers, how far away am I? My score minus the mean. Now, this can be a negative number, right? If the class average on the quiz was a 50 and I scored a 40, this is going to be a negative 10. So this can be a negative. Z-scores can be negative, and we'll get there. So to start off with my z-score, my score minus the mean. But then I have to do something else, right? Because if the class average was a 50 and I got a 60, I know that I'm 10 points away, but I don't just want to know the amount of points away I was. I want to know how many standard deviations away I was, right? Because to return to an example we used last week, if I scored 10 points higher than the mean, but the standard deviation was a 2, that means I'm 5 steps away, right? If I scored 10 points away, standard deviation was 1, or was a 10, I'm 1 step away. And that's exactly the last step of this process, is we divide by the standard deviation. How many standard deviations away am I? So what that gives us is that your formula, put my z bigger, your formula for figuring out your z-score, the score you're looking at minus the mean divided by the standard deviation. And you can logic that out, that is a way to figure out how many standard deviations away from the mean am I, as the specific score we're looking at. And we'll fill the rest of this in on part 2.